Hi, welcome to Hashtag Math. It will all make sense. We're going to work out the derivative of the logarithmic and the exponential functions and give some examples involving them. So to derive the exponential function, we use the fact that e and ln are inverse functions and use the derivative of e to the x. So let's rewrite b to the x. Because e and ln x are inverses, e to the ln b equals b. Now, if we raise both sides to the power of x, we get that b to the x, the exponential function, is e to the ln b times x, because here we multiply being a power of a power. Now we derive both sides of this equation, so we do d dx of b to the x is going to be d dx of e to the ln b x. And we have the chain rule. The inner function is ln b times x, and the outer function is e. So we derive the outer function, keep the inner function in, and derive the inner function. So this is e to the ln b x, and the derivative of ln bx is just ln b. You understand why? Yep, ln b is a number. So ln b times x is something like 3x, whose derivative is just a number. So the derivative of ln bx is just a number, ln b. And we're almost done because e to the ln bx is just b to the x as we did before. So we replace it. We get b to the x ln b. So the derivative of the exponential function b to the x is just b to the x times ln b. Now we derive the logarithmic function using the derivative of ln that we found before. Remember the change of base formula? So we write the logarithm to the base a of x in terms of the natural logarithm, which is ln x over ln a, and then derive both sides. So d dx of the log to the base a of x is d dx of ln x over ln a. Ln a is again a number, so it comes out from the derivative. So this is 1 over ln a times the derivative of ln x. And the derivative of ln x is 1 over x. So this is ln a times 1 over x. And so the derivative of the logarithm to the base a of x is just 1 over x ln a. And we can add these two guys to our table of derivatives. Two more. Now we work an example that has log to the base 3 on it. Let's derive y. And as you can see, this is a composition. And when we have a composition, we do what? Chain rule. So the outer function is the log, and the inner function is the square root of 3x squared plus 1. And we derive the outer function. We just learned that the derivative of logarithm to the base 3 is 1 over, keep the inner function 3x squared plus 1, and multiply by ln of 3. Then multiply by the derivative of the inner function. And we get 1 over ln 3 square root of 3 squared plus 1 times the derivative of the square root of x squared plus 1 is again a chain rule, where the square root is the outer function and 3x squared plus 1 is the inner function. And we apply the chain rule again. So this is 1 over 2 square root, and keep the inner function there. And then we multiply by the derivative of the inner function, which is 3x squared plus 1. And so we get 1 over ln 3 root 3x squared plus 1 times 2 times root 3x squared plus 1 times the derivative of 3x squared plus 1, which is 6x. Now, 1, 2, and the 6 cancels out with this 2, leaving me a 3. And the derivative is going to be 3x over ln 3. And then, when we multiply square root of 3x squared plus 1 times square root of 3x squared plus 1, we get just 3x squared plus 1. And that's the answer. Another example. Let's derive y. what do we have? Again, a chain rule. The log being the outer function and 8t to the ln 2, the inner function. So the derivative of the log to the base 2 is 1 over, you keep the inner function and multiply by ln 2. And then derive the inner function, t to the ln 2 times ln 2. And then when we derive 8t to the ln 2, the 8 stays there. It's just a constant. And now look at the exponent. The exponent is ln 2. Again, ln 2 is a number. So when we differentiate t to the ln 2, it's like differentiating t, I don't know, to the fourth power. Means you just put the 4 in front and subtract 1 from the exponent. So we do that with ln 2, which is a number. So we get 8 times. Put ln 2 to the front and subtract 1 to the exponent. Now the 8's cancel out, ln 2 cancel out, and we get t to the ln 2 minus 1 over t to the ln 2. And we just use power rules. This is t to the ln 2 minus 1 and subtract the power in the denominator, which is ln 2. ln 2 cancel out and we get t to the negative 1, which is 1 over t. So our answer is just 1 over t. And this is the last example of the video. We're going to derive this function to acquire experience using e to the x. So the derivative of y equals what? Again, chain rule. Outer function ln, inner function e to the x over 1 plus e to the x. Derive the outer function. The derivative of ln x is 1 over x. So we do 1 over and keep the inner function there. E to the x over 1 plus e to the x. And then derive e to the x over 1 plus e to the x. This is telling us to take the reciprocal of e to the x over 1 plus e to the x. 1 plus e to the x over e to the x. Now let's derive e to the x over 1 plus e to the x. And that, of course, is the quotient rule. So we do low, d high, minus high, d low, square the bottom, and away we go. So this is 1 plus e to the x over e to the x. And let's derive. We get 1 plus e to the x. The derivative of e to the x is e to the x minus e to the x. And the derivative of 1 plus e to the x is just e to the x, because the derivative of 1 is 0, all over 1 plus e to the x squared. So this equals. I'm going to rewrite things being very careful. Now we use the multiplication of fractions. In the denominator we get e to the x, 1 plus e to the x squared. In the numerator we get 1 plus e to the x times. Now what I'm going to do is factor e to the x from these two terms. You see, e to the x repeats here and here. So I'm going to factor e to the x, and we're left with 1 plus e to the x minus e to the x. And these guys cancel out. E to the x cancel out. And this 1 plus e to the x cancels out with this here. And my answer is 1 over 1 plus e to the x. Thank you.